Hello students. Today we'll start the new chapter that is Introduction to the Trigonometry. It's a 8th chapter of part 2 of class 10 mathematics. So we'll discuss the syllabus concepts. That is, first one is introduction of the trigonometry. Second one is trigonometric ratios. Third one is trigonometric ratio of some specific angles. And fourth one is the trigonometric identities. And the summary of the whole chapter. Okay, we'll go for step by step one. So we'll start the introduction of the trigonometric. Okay. That we discussed about the syllabus of the trigonometry. Now we'll start the introduction. We have already studied about the triangles, the triangles, and in a particular right angle triangle, that is 90-degree at one side in your earlier classes. Let us take some examples from our surroundings where right angle triangles can be imagined to be formed. Okay, first one, the Qutub Minar in Delhi. When you visit with your friends, suppose there are students of a school are visiting Qutub Minar. Now, if a student is looking at the top of the Minar, a right angle can be imagined to be made as shown in the figure 8.1. You can able to see here 8.1. A student is standing like here and watching the top of the Minar. So it will form the right angle triangle. Can we find out the height of the minar without actual measuring? Can we? So you have to think about it. And next we have the another example. Suppose a girl is sitting on a balcony. You can see in 8.2, in figure 8.2. Suppose a girl is sitting on the balcony of her house located on the bank of the river. She is looking down at the flower pot placed on stair of a temple situated nearby on the other bank of the river. A right angle triangle is imagined to be made in the situation as figure 8.2. If you know the height at which the person is sitting, can you find the width of the river? See, if you seated on the balcony of your house and there's a river bank, see that you can find the distance width of the river by the height, or if you get the length of there, will you? So this is the question. The third example is, suppose a hot air balloon is flying in the air. A girl happened to spot a balloon in the sky and turn it her mother to tell her about it. Her mother rushes out of the house a look at the balloon. Now when the girl has spotted the balloon, initially it was point A. So generally it's moved. When both the mother and daughter come out to see, it had already traveled to another point B from point A. Can you find the altitude of B from the ground? Can you? So these are the question arises. So we'll discuss in this chapter how to find the length of there and height of that and the distance like this. Okay. So the introduction of the trigonometry. So now we'll discuss the definition of the trigonometry, and the word trigonometry basically come from which language and how it will divide it. Okay, so the the definition of the trigonometry is a branch of mathematics. Definitely, it's a branch of mathematics that studies the relationship between the sides and the angles of the triangles. You know, the sides and the angles of the triangles. Okay, the word trigonometry is derived from the Greek word that is trigonometry. Tri means three, gon means sides, and metry means measure. The whole chapter is only for the tri means three sides of the measurement. We have to measure the three sides of the given triangle. Okay, students, in this chapter, we study trigonometry only for the right angle triangles and only for the acute angles less than 90 degrees. Okay, the 90-degree means right angle triangle, and less than 90 degree means it's a acute angle and greater than 90 degree means it's an obvious angle. So we'll discuss in this whole chapter only for the acute angle, that is theta. Okay, now discuss about the right angle triangle. What is a right angle triangle? Right angle triangle is 90 degree. Right angle triangle, one angle is 90 degrees called right angle triangle. See, there is a triangle. Okay, it has three angles, that is A, angle B and C. So any one of the angle should be 90 degree. So here B is 90 degree. So we tell it as right angle triangle. A triangle one angle, that is ABC. The triangle B is 90 degree is called right angle triangle. Okay. Now consider an angle ABC. We have an angle ABC. In that ABC is 90 degree. Triangle angle ABC, that is B is equal to 90 degree. We can also write it as a B is equal to 90 degree. Okay, so for this reason we call it as a right angle triangle. Similarly, we another thing we have the angle, that is theta, that is C is equal to theta. It's a very important. We have to find all time the theta. So okay, the next topic is naming the side of right angle with respect to the angle theta. The sides are named as. So you can able to see the right angle triangle. I draw two right angle triangles. First one here, ABC. Here this is B is right angle triangle 90 degree, and this is the theta angle theta. Here you can able to see. Uh, we have three main concept here. First one is the hypotenuse, and second one is the opposite side, and third one is the adjacent side. Okay, first discuss about the hypotenuse. So the side opposite to the right angle 90 degree is called the hypotenuse, or longest side of the triangle. In the both the triangles you can able to see the longest side of the triangle is, in the first image it is A to C, that is AC. In the second image it's also AC. In the second image you can able to see A to B it is 1 centimeter consider, and second one is B to C it is 1 centimeter. Then A to C should be 2 centimeter. Hypotenuse is always a greater side of the triangle, or the longest side, or the it's a very lengthy, so it's easy to understand. Second one is opposite side. We have the triangle. In the triangle we have the opposite side. Opposite side, nothing but side opposite to the angle theta. So sometimes they will not mention like this. They will give like the second triangle or the first triangle. That time we have to be referred to the angle. If the theta is given to the C side, then the opposite side should be AB. If the theta is given on the side C in the second image, the opposite side should be AB. If the theta is given at the A, then opposite side should be BC. The opposite side is nothing but the opposite side to the angle theta. Okay. The third one is adjacent side. So you know the opposite side and the hypotenuse, the longest one. So the remaining only one side is left, so that is adjacent side. So side next to the angle theta, side next to the angle theta. See, we have two sides which are coinciding here at the C, so they will create the angle theta. So the side next to the angle theta is called the adjacent side, that is BC. So the important note is here, the names opposite and adjacent, that is AB and BC, may changes when the reference angle changes. I already told, if the theta is given at the A side, angle A side, then opposite side will become BC and adjacent side will become AB, but hypotenuse will be remain same, that is AC. Okay, we'll use the Pythagoras theorem also to find the angles, but before that we have the another before that we have some trigonometric ratios. In that, first one is sine theta, that is sine ratio. Second one is cos theta, that is cosine ratio. Third one is tan theta, that is tangent ratio. Fourth one is cosec theta, that is cosecant ratio. Fifth one is sec theta, that is secant ratio. Sixth one is cot theta, that is cotangent ratio. Okay. We will discuss about the what is sine theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta. Okay. Now we'll discuss the relationship between the trigonometric ratios. As we know, we have six trigonometric ratios. Uh, in that, now we have three. Discuss the reciprocal relationships. First one is cosecant theta. That is cosec theta is equal to 1 divided by sine theta, and sec theta is equal to 1 by cos theta. Cot theta is equal to 1 by tan theta. We can also write sine theta is equal to 1 divided by sec theta, cosec theta, and cos theta is equal to 1 divided by sec theta, and tan theta is equal to 1 divided by cot theta. Okay. Similarly, we have 1 divided by sine theta is equal to, we know, that is 1 divided by sine is nothing but cosec, 1 divided by cos nothing but sec theta, 1 divided by tan is equal to cot theta. So sine theta divided by cos theta is equal to tan theta, and sine theta divided by cos theta is equal to tan theta. Cos theta divided by sine theta is equal to cot theta. The reciprocal of the tan theta is nothing but cot theta. Okay. Thank you.